So hi everyone. Okay, live streaming is on now. So hi everyone. Thanks for joining. Thought maybe we could start with a short introduction round. I mean, I guess most of you know each other. Spent a lot of time in meetings and so, but let's do it anyway. So I guess ladies first. So I'll go first. It's the only one here representing ladies here. So yeah, my name is Danielle. I'm a community manager, and my headset is going like on mute really randomly. So just like wave if you cannot hear me, because I don't know when it's doing that. So hi. So everyone that introduced just like name someone else and then they would introduce themselves. Let's do it this way. Cyan.
Hello, so I am Cyan. I work with the Flatcar team, primarily looking into the releases. And yeah, we're handing over to Steven.
Hi, I'm Steve Harris. I work with Coinbase, and I'm here to pursue an issue that's plaguing us. We're enthusiastic Flatcar users. Next up, Jeremy.
Can you hear me? Yes.
Yes.
I guess. Wait.
How about now? Now even
Yep.
better. Yeah, so I'm Jeremy. I'm also on the Flatcar team. Been looking into some kernel issues recently. Been looking at ARM64, and that's why I'm here. William.
Certainly. I'm William. I'm on the Flatcar team at Microsoft. Good evening from Rotterdam in the Netherlands. I'm mostly just kind of generalist developer stuff, working on some OpenSSL wrangling at the moment. Mathieu.
Yes. Hi, everyone. So Mathieu from France, working currently on Ignition and SLinux related topics in the Flatcar team, yes. Handing off to Lennart.
Hi, I'm Lennart. I work on System Upstream. I don't really work on Flatcar at all, but I was invited here today together with Luca.
I go next.
Oh, and Luca, yeah.
Hey, good afternoon afternoon from Scotland. I'm Luca. I'm a systemd upstream developer, Debian developer, and I work as an engineer in the Linux systems group at Microsoft. Not Flatcar, but similar stuff. And next, Thilo.
Hey, I'm Thilo. I work with the Flatcar team at Microsoft. And over to Timothy.
Hey, I'm Timothy, and I work at Red Hat on Chorus systems, so not Flatcar, but similar systems. And I forgot to tag somebody, sorry. Who's left?
I can go next. I think I'm the last one. So hey, I'm Krishimir. I'm also a member of the Flatcar team at Microsoft. Currently mostly working on keeping our distro relatively up to date. Yeah. And I guess I was the last one. So pending. Oh no. Kai is still there. Yeah. So next guy.
I'm based in Berlin, also in the Flatcar team at Microsoft. Okay, and the second Luca can also introduce himself. Okay.
It's the same Luca.
Yes, you have two of me now. Does it mean I get paid twice? No.
Well, you're getting paid to be here?
I guess Matthew is also here. Camera is not on, so I don't know.
But Matthew already spoke, didn't he?
But Matthew said hi from France. Yeah.
All right. Sorry. Yeah. Just checking if you're alert. I guess that concludes everyone. So how about we start with the agenda? I mean, it would be nice to still see you guys, so I won't be sharing. I'll just post a link to the agenda here quickly. Right. So first is sorry, I think I got muted. Yeah. So talking about our new Jitsi server. How about you take it?
Yeah. So we moved away from Zoom on Jitsi because the Zoom free count only gives you 45 minutes of meetings and streaming, and the office hours sometimes take a little longer. So we just basically set up our own instance. You all found here, so you already know. For everybody on the stream, is not as bad as it used to be with Jitsi. It's pretty amazing since the advent of Dockerized images for Jitsi that are maintained upstream. So we don't take any of this credit. We just basically ran Docker Compose and things just work, which is amazing. But yeah, we're pretty much on our own Jitsi instance, which is proudly sponsored by Equinix Metal, which is a great embedded cloud.
And you just scared everyone that the meeting is going to take longer than half an hour. No.
Sorry, that's manager me speaking. I'm sorry.
Yeah.
All right. Yeah. So last week in Berlin we had the immutable. The image-based Linux summit, and immutable systems, large part of that. And Leonard and Luca ran the show and did actually a great job in doing so. We were just amazed as one part of a much greater community. We had folks from Ubuntu, SUSE, Fedora CoreOS, Arch Linux, and I probably forgot half of this. We're working out a minutes, so there's like a detailed thing later on. But enough from me. Just give the word to the folks who ran the show. Luca.
Thank you. Yeah, I can get started and have a couple of minutes to have a quick introduction, and then maybe we can look at a couple of topics in more details. So Leonard, myself, and Christian Brauner, who is the other organizer, but he's not here because he's on holiday, the Skyver, imagine that. But in the past few years, we've been working on the generic topic of image-based Linux with a heightened interest on security. Both because of the internal projects at Microsoft, but also from external inputs and requests. So we spent a lot of time, thinking, tinkering, pondering, and then at some point we realized that a lot of vendors and distributions are pretty much working in the same or similar areas, doing similar enough things, but more or less everyone in their own way, in their own corner. So at some point we thought, can we do better? Can we establish some collaboration patterns? And at the very least, have a shared understanding of the space and the terminology, the concepts, maybe specifications, if not implementations. So from this, then we quickly come to the idea of organizing a summit. The idea was to have a small meeting, so 30 people or so, from a representative section of the industry, at least from those vendors and groups and organizations that have shown to be working in this area and these topics, and invite them, get all together in a room and just talk about stuff. And so it was. Last week, as Theo said, we met in the Microsoft office in Berlin on the 5th and 6th of October. We had 30 participants. This was, again, intentionally invitation only. It was not open to the public. It was not recorded. We will not publish videos or anything. We publish a summary and minutes and so on. But we intentionally wanted to have a free flow of discussion and topics. It was pretty much a birds of a feather style session. So as Theo said, we had many participants. We had Microsoft, Red Hat, Ubuntu, Debian, SUSE, Amazon, Meta, Flatcar, Arch Linux, and a couple of independent developers as well, and I'm sure I forget some. There's a list somewhere. So we met there. We talk about these topics for 2 days, and in the end, we are, I say, quite pleased with the result. We came away with quite a number of action items. We are going to establish a repository where we will gather documentation and specification that are common to all the projects and people working on these topics. And we're working on that right now. We hopefully will publish that very soon. It's just a GitHub organization with a couple of repositories. We have a lot of action items on systemd because many of these features depend or use systemd tools. And so we have a number of RFEs. Yeah, that is the generic short summary of what we did and why. Now we can cover a couple of topics in more details. I think a lot of these apply to Flatcar. And of course, what we noticed very quickly is that there is some overlap with many of these projects. There's not a perfect overlap between all of these parties, but there are a lot of similar concepts. For example, there's two diverging ways of doing things. Like there's the image-based, where Flatcar and the Microsoft project do that. We supply immutable images to systems, and there is a slightly different way to do things with RPM OS3 or with Butterfly volumes. Just to give you an idea of where the difference are, but the core concepts are the same. We want to have systems that are immutable, that have enhanced security by default, that we use the TPM and the Verity and so on and so forth. So just to cover a few of these concepts, we introduced, there will be a lot of acronyms now, so brace yourself. So we talked about UKIs, Unified Kernel Images. So what these are secure boot signed single files that wrap a kernel image, an initRD, and a kernel command line, and optionally a few other things. Why do we want this? Because you can have a single file that you ship and you put in your EFI partition, and then you can boot with secure boot for verification, or that can be easily measured into the TPM because it's one thing, and it's read-only, so it gives you the additional security. We talked about DDIs. So what's a DDI? It's a discoverable disk image. What is that and how it relates to UKIs? So a DDI is a self-described image. By image here, I mean just a raw GPT file. GPT is the partition table. So following the DPS, which is discoverable partition specification. I hope someone taking notes here. The discoverable partition specification basically allows you to self-describe a partition on a GPT disk with well-known GPT labels. You can say, okay, this partition is a root file system. This one is a /usr file system. This one is var. This one is home. This one is the Verity. Because, of course, all of these are support DM Verity as a first-class concept, so that for those who are not familiar, DM Verity allows you to have offline and online integrity checks enforced by the kernel. So every read of your block device is enforced in integrity by the kernel itself, and it can all chain up to a signature that can be validated by the kernel. So with DDIs, and so with UKIs, you put a kernel image with initRDs, and then you transition into your DDI, which can be a root file system or as a user file system. These DDIs are a single concept that applies to many tools and systems. So not only to your system as it boots, as loaded by your UKI, your unified kernel image, but also, for example, to portable service or an NSpawn container, or they can be used to overlay additional files on top of your system. So we move to the next concept, which is the system extension. So this has been available in systemd since 2 years ago-ish. Again, the system extension is a particular type of DDI, so it is self-described, it's a GPT, it's Verity protected, signed, blah, 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 blah. it allows you to extend a read-only file system with additional binaries, files, and whatnot. Again, same concept. This applies to many different components. It applies to your root file system, in which case it extends /user or optionally /opt for vendors, third-party vendors. It applies to system services. So in your systemd unit, you can have extension images and point to a DDI. It will automatically overlay just for that service the additional files in /user or /opt. This applies to SBOM containers, to again Azure root file system, as I just said, and so on. Again, we have the same idea across all these components. We take one item and we make it work across your root file system, your initrd, your portable service, your system service, your SBOM container. So exactly the same format, same image, same concept applies to throughout the whole system. And given I touched on initrds, one of the big topics was how can we fix the glaring security holes that we have right now with initrds? If you are not aware, right now you can, on Linux, on a standard Linux distribution, you boot Debian, you boot Ubuntu, you boot Fedora. It's secure boot protected, so your kernel is signed, your kernel modules are signed, your disk, if your rootfs can be encrypted and sealed against the TPM, your firmware is signed, but your initrd is still built locally every time on each and individual machine. It's unsigned, it is unprotected, it's writable. So an attacker that gains write access to your disk can just inject their binaries in your initrd, and there is absolutely nothing you can do about it. After you transition into the full OS, the attacker has control over it. So how can we fix this? The idea is to use the DDI, UKI, and SysX concept so that the initrd too is read-only and signed and shipped by the vendor. So the vendor builds it on their server to share secure and lockdown and ships it to the users. Of course, the reason why we have initrds built locally is that they need to change depending on the hardware. So we are proposing to use extensions so that the basic initrd is fixed and the same for everybody, but then you have various extensions that add NFS drivers or BTRFS drivers or other network thing or whatever it needs. So we will build a dozen of extensions and they will be used on demand only when needed. This is going to be, if everything goes to plan, going to be proposed for Fedora 39. Another concept that we talked about is the system configuration. So if your system is read-only, how can you update securely your configuration because you want to change a parameter of a random daemon, for example? Well, the idea that we want to introduce is, again, following the same pattern as before, the syscfg. At some point, I will learn how to spell that out. So that stands for system configuration. Again, that is a DDI, and it overlays on top of /etc instead of /user. But same concept, the enverity protected can be measured as one thing. You can have multiple one of them. It applies to your initrd, rootfs, services, etc. Another topic that we spent a lot of time on was Tpm based security. And so right now, what everybody does is measure into it. So if to try and give you a bit of an idea, a TPM is a secure chip on the system that has an event log where you can append only certain information called measurements. Basically, you append hashes to it. After you append a hash to it, you cannot go back. So this is used as a way to seal, and of course it has secret keys in it. So you can seal secrets against particular measurements. And the idea is you measure your firmware, your kernel, your components, and then if everything matches, you unlock the secret, say for your disk image. Now, the problem is that if you measure hashes, for example, of your rootfs, and you update your rootfs, the hash doesn't match anymore. So that requires re-enrolling everything every time you change even one component, bootloader, kernel, kernel modules, initrds, rootfs. That is kind of a problem. So Leonard came up with an idea to instead measure against signature of PCR hashes. Leonard, do you want to speak briefly about this to put you in, because I've been blubbering for a long time.
Sure. So we don't measure signatures. We still measure the data and generate the hash values from it. But then we actually, instead of binding our secrets to specific hash values, we bind our secrets to signatures of hash values. And by doing so, as long as so basically when you enroll your disk encryption scheme, when you install the OS or when it first boots up, you basically provide a public key that says whenever, for example, a kernel is booted for which a PCR signature can be provided that matches the PCR values currently in place, then release the secret for disk encryption to the OS. So this, for the first time, gives us a way how we can, in a non-brittle, like in a robust way, lock disk encryption even like in non-interactive setups, right? Like where the system shall be able to boot up unattended. Yeah, that we basically release a secret only when the software is truly in order and we don't have to re-enroll every time we do an update. This actually, today I wrote a long text about this, which we like on request of Microsoft management, so that we can inform other parts of the company about this, in particular Marina and Flatcar, I guess. Though the Flatcar people should probably mostly know this already. That explains all these details. That's a lot of stuff to take in because it deals with UKIs and TPMs and PCRs and signatures and things like that.
Loads of acronyms.
Lots and lots of acronyms. So I tried hard in that document, which I guess I could share here. It's currently on Google Docs, though, because I wanted cooperation with some people outside of Microsoft. Yeah.
Did they forget anything about DDI, CCFG, CZEX, and all of that? Was it a good enough summary?
I think it was good enough summary. I mean, the key really is that we can compose this entire system at runtime from all these DDIs for different purposes. And I think this is a great opener for future stuff. Like, for example, you could express things where you say, I want this configuration extension to only apply to a local system in this time frame when the software is in order and things like that. And thus you can use it for deploying secrets that need to be rolled over and things like that, where you can cryptographically make sure that if the systems don't catch up, they lose access to your cluster and things like that. So yeah, but that's something we still need to write up, I guess.
Yeah. So there was a lot of interest in many of these components. For example, there was a lot of interest in the system CCFG. So I think we will see a lot of vendors try and come on board with that. Other things we talked about. How long do we have? I'm keep blabbering.
Well, you gave a great intro. I don't think we have time to dive into details, but we should definitely go over the big chunks.
Yeah,
and
so
of course,
just-
I mean, if there's any updates, right? This is just a developing thing. We just kicked this off. If there's any updates, we will absolutely make sure to cover them here, or like any better place that we find. So this is not a one-time thing. If you don't want it to be.
Yeah, absolutely. So just to conclude then, the key takeaway is that we are forming a GitHub org. We will start from a specification for the DDIs, CCFGs, and the location they are at, and to look for UKIs and the partition names and a couple of other things. For example, boot assessment, a standard way to say, yes, my boot was good, or no, my boot was bad, roll back. So we'll start from with this group of people, and then we hopefully make it public in the next few weeks once we have put the pieces in place, and then take it from there. Allow input from everybody else. We want input from not just from these people, of course. It was just the start, but from the whole community. Yeah, that's it for me.
Just to mention this, I just dropped the link to this document I wrote about the brave new trusted boot world into this chat. It's not really supposed to be public. Please don't send this out on some public website. But if you're interested in further details, please read up and comment on it. That would be welcome, very welcome. I will eventually turn this into a blog story.
Okay, thank you for having us.
Okay, so I really got all the details. I remember all the acronyms now. I know it all by heart. You can ask me whatever you want, but like, let's take it maybe as a segue. I'll do it later if you want. You could stay. But like, maybe Jeremy got the next item in the agenda. It's like more now Flatcar and specific. So some update about the ARM64 SDK, SBOM, and yeah, so then it would be a segue to Thilo again. So Jeremy.
Yeah. Okay, I'll go ahead. So last year, Flatcar finally brought ARM64 support to the stable channel. Something we didn't do in this same course was we never ported our SDK over to ARM64, mostly because last year we didn't really have great access to ARM64 build servers. But since Azure announced general availability of ARM64 nodes and more users have been using our container SDK on MacBooks, we've had lots of requests come in to see if we could make it work on ARM. And so I started looking at it. The issue here is Flatcar is built using Gentoo tooling. It starts from everything started from some kind of SDK that was created ages ago, and then since then we've been re-bootstrapping this SDK with every release. So there's a 3-stage bootstrap, starting from like base packages and then extending the SDK with compilers, tool chains, rebuilding itself, and that's how we come up with an SDK. So I'm still in the progress of making this work for ARM64. Went through the bootstrap. We have a base SDK that would work with the tool that we used to use, which was Cork. Nowadays, we've migrated to a Docker container SDK. So I'm still working out how to properly publish this SDK. I don't actually think what we have right now is usable by anyone. Although if someone's interested in collaborating, that could work, because the bits for a single release, which is 3346, are public on our bin cache server. So anyone could pull them, anyone could reproduce the current state. And yeah, in the coming, I guess, months, weeks, it's going to turn into like a proper thing. I think we'll mostly publish it for like development purposes. Not really. I don't believe we have any intention of building like cross-building x86 releases from ARM. Definitely wouldn't be the easiest path, but yeah. If anyone has a MacBook, anyone wants to play around, I don't have an M1 MacBook, so I can't test this, but we have some nice Ampere Ultra servers. Yeah. So that's that item. Any questions?
No, just say love it. Basically, put the Mac users into the driving seat to do operating system development.
Yeah, absolutely. We're always happy to hear of users hitting like limitations, and then we love to extend Flatcar for them. Next item on the agenda is the SPDX SBOM, which is actually something that Thilo started. Wait, is it? No, that's the salsa. Okay. Yeah, so SPDX SBOM, I believe we've always published an inventory of packages, licenses, and files in our images. They're on our server since forever. We use a JSON format because, well, we first came up with this, I guess, 4 years ago. At the time, the SPDX ecosystem was not as developed as it is now. So some month ago, we found that I think the tool is called Sift. that one of the Gentoo developers contributed support to Sift to generate SPDX formatted SBOMs based on Gentoo root file systems or container images. We pulled that into our build process, and so since then we've started publishing an SBOM in SPDX format. I don't know what it works with right now. Like, I think it's mostly for your information, but hopefully we find some nice use cases for this where SPDX SBOMs are asked for. Potentially mix this in with our provenance, right? Have some chain of like kind of artifact flow. And yeah, like we're excited to see where this what kind of innovation this leads to. Right now, publish on our service with every release. Check it out if you need them. If your auditor ever asks you, hey, do you have an SPDX SBOM for the OS you're running? Well, now you can say, yep, they'll tick the box and move on to the next item to bug you with. And that kind of segues into Thilo, because Thilo's work was very related.
And you say my work, and that's not entirely true, because I did like the easy part, and then I somehow nudged you to do the hard part of SASA provenance generation. So, and for that, I'll share my screen. First time ever that we use Jitsi screen. No, actually, that's not true. Cyan did it before. All right. So in the office hours agenda, you'll find a nice link to our supply chain documentation, which should be on your screens now. It has like a general part explaining what SASA is and having some references to the official documentation, and kind of a checklist on what we see, how like what specifications, what requirements Flatcar meets in SASA. And then the more interesting part, which gives you an overview of how we generate provenance and how we store it. All right. Now we need to share another window, because now we want to look at the actual generated provenance. That is part of the new Flatcar images. And it's a feature of the new build pipeline that we just switched over to, which also uses the containerized SDK. So you're seeing a screen now, and that's just directory where I downloaded like the most recent Flatcar Alpha release. The current Flatcar Alpha and beta releases contain the provenance stable coming out this week. We'll have it as well. So let's quickly start this up, and then have a look at the file system and see where the provenance is. So provenance is basically cryptographically secured inputs processed to build something and outputs. And we apply the provenance part to all of the packages that we build. And the outputs basically consist, is what our user partition, our operating system binary partition consists of. Things are stored in /usr/share/SLSA. That's a non-standard path, but I don't know about any standard paths. So we hope this is useful. It's basically, so SASA defines a JSON format that will structurally list the inputs, the build commands that you're using, and the outputs that the build produces, and you have that for every single package. So if you look at for instance, bash, that's the SASA provenance for bash. So it's just some basic headers. Invocation is you check out the repo, and that's how you build Flatcar nowadays, right? You check out a repo, in the repo you check out a tag, and then you run a script. It's entirely stateless. All of the build information is in the repos already, and that is reproduced here. So you get the whole build. Now, the input materials for bash are basically the bash, or for any package, are basically its tarball and any given numbers of patches, and the build instructions. Now, the build instructions here are right from the Flatcar Git repository that contain the respective ebuild and the SHA-1 of the respective checkout that we've been using for building this specific bash package. Then there's the bash tarball, which is cryptographically secured. So we have a checksum on that, and any of the patches that we apply on top of bash. So you could basically go get those, check the checksums, check the checksums of the build instructions, and you can reproduce this build. And out comes what Salsa calls the subject. So that is basically all of the bash binaries that we ship in the release image. And those are to cryptographically checksum, so you can validate at any point in time with all of the inputs, and you'll basically check all of the outputs. Now, the checksums currently are a little bit, I would say, naive. And the reason for that is that parts of binaries change when you recompile them, because the compiler puts in like the host, the things were built on, the build time and whatnot. So all of this transient information kind of changed the checksum. However, as kind of a future improvement, we could just check the binary parts that actually executed and leave alone the parts that have no influence on the execution but contain transient parts. So our builds are 100% reproducible. You will get different hashes depending on the circumstances, but the binary parts are exactly binary the same. And this is mentioned as a caveat in the Salsa documentation as well. All right. Oh, next thing is me as well. It's the new pipeline. I'll be much briefer with this one. It is again screen sharing time. All right. So after switching to the new SDK in development, which is built on a container instead of Cork, we've now integrated the same thing with our CI pipeline and test pipeline. And we have a number of lightweight stubs that let you use this pipeline to connect to any build system if you so desire. We have the build steps described here. And this is like the other part, the back end of the work that makes our builds reproducible. In that work, all of the state that we have to reproduce any build are part of the script repo. The scripts repo for all of our releases contains tags that definitely qualify our releases. So if you just check out those tags, update the Git submodules that we're using for the eBuild repositories, then you have the exact same state that we use to run a build.
Okay. The next item is of Seance. It's about, yeah, okay, maybe you could just take it, but it's about Flatcar availability on ARM64 Azure Marketplace.
Yes, so I'll be quick because we are about over time. So we did, and also like I seeing Thilo, I think I would do a demo next week on the same to show. But now that we, so we have had Flatcar on marketplace, the general images on marketplace for from the beginning of time, but recently we after some work we have finally published the ARM64 images on the Azure marketplace. So you could now spawn up your ARM64 workloads on Azure on the ARM64 using the ARM64 images. I'll do a quick I try to show quickly on how to do that. So if you are if you open your my Azure account, you can go to the marketplace images. You'll see if you search for Flatcar container Linux, so it lists all our images, like the pro ones, the regular ones, but now you have a ARM64 entry, so you can just click on it, and we have it for all the channels, alpha, beta, and stable. So you can go as per your need, and you can go ahead and create your images. Yeah, that's from my side. Over to Daniel.
All right. So I think I was muted again. randomly. Yeah, so the next item is Casper. Some kernel update fun.
Yes, basically what I wanted to talk about is what workflow do we use to update kernel. It's like not even about the kernel updates. It's more general thing. But the kernel updates are usually biting us most often. So the thing is about what workflow we should have for updating the kernel for the stable maintenance branches. The stable maintenance branches, I mean the stable channel and the LTS channel. Because so far we have been basically tracking the patch releases of the kernel, and if they appeared, we just merge them to the branch and release it. Yeah, just expect things to work. But apparently the kernel is like, those patch releases are not that really stable. People started complaining that some patch release just broke something. Yeah, so it happened several times. So I started wondering what kind of workflow we could have for updating the kernel versions. So initially we came up with the thing that we update the kernel for beta, we release beta, and then we wait 1 week. So people running the testing machines have like a 1 week, or I don't know, 1 week is just a proposal, could be 2 weeks or something like that. But for now we run with 1 week. 1 week for testing the beta release, and if there are no issues, we propagate the kernel update to stable. But the issue with this one is that LTS channels don't have the same major version of the kernel. So currently, beta and stable have kernel 5.15, whereas LTS has kernel 5.10. The old LTS that we are still supporting for for how many weeks? 2 weeks left, has the kernel version 5.4. So we don't have this unstable channel that we can tell people, if you are using LTS, then use this channel to test this LTS before it hit the proper LTS channel. So currently the kernel updates for the stable channels are on hold. Kernel updates for the stable channels are on hold until we figure out what workflow we should have for the kernel updates for the stable maintenance branches. I have a document. Oh, I think that someone already pasted it. Like, oh yeah, cool. So there's in the chat, there's a document when I wrote basically what I'm talking about right now. And there are like several proposals. I probably will talk about only one that I have that I think that mostly makes sense, is to have two separate channels again. So my idea was to have like a stable testing or a pre-stable channel, the same with pre-LTS, that would receive all the updates on the fly, and then we would from time to time release some pre-stable version for people to test. And then when everything works, then the stable channel would become a snapshot, a working snapshot of the pre-stable that we know that works. So that would be my idea. I think I went with this idea because this is a thing that would also work with our Nebraska server. That we can just add some new channels to Nebraska. We already did that in the past with like Edge channel, something like that. Compared to other proposals that I have in the document, like even odd versioning scheme, that wouldn't work very well because we would need to make more changes in the in Nebraska, in our release machinery. So I'm wondering if this would be the way to go. If you have some comments about it, to have like 2 additional channels, because the stable channel at some point will also be the channel that has no beta channel for kernel updates. Because I think that 6.1 is going to be a new LTS kernel, so there's going to be a window when beta channel gets updated to 6.1 and the stable channel is still at 5.15. And again, we have no extra channel to have like a testing changes for the kernel updates, not for the stable channel. Yeah, so I came up with that. Do you have maybe, I don't know, some ideas? If not right now, then there's a document in the chat. Please comment. And yeah, I hope that we can find out some solution to this situation and implement it, so we have more stable branches. Thanks. That's all I had to say.
All right. So next up is Steven. It was all like fun and exciting stuff that we do. So let's talk about, how should I phrase it? Growth opportunities or what?
Let's try. I think probably a lot of you have seen this bug report that I submitted about a year and a half ago now. Back at the time, just real quickly, on machines running in AWS EC2 on a very heavy network load, the kernel crashes. The machine reboots pretty quickly. And a long time ago, we figured out, we kept going backwards through Flatcar releases, and we settled on something like beta 2705, I think was, like, it didn't crash anymore. So we used that for a really long time. And we've been in the season now. Again, we're trying to upgrade our Kubernetes clusters and started trying to push for using newer Flatcar versions. And what do you know? This bug comes back. The line number changes because the source file where the bug arises has been evolving a little bit, mostly through 2021. And we don't have, our machines don't have pstore enabled, or whatever it takes in the hardware. So I wasn't getting any good call stacks reported. But a colleague of mine was doing a lot of testing to help and discovered that on some of the fresher kernel versions, we could push this into situations where we would get the call stack printed. So it seems related to, like I said, heavy network activity. And there was another user named Igor, I don't think it's here, who had proposed that if we disable the generic receive offload and generic segmentation offload, that he saw that the problem went away. We've been experimenting with that over the last week and a half or so. And I can confirm that when we disable that GRO and DSO feature, the kernel stops crashing, but the network performance is abysmal. So, so we've experimented like, well, what if we turn one of them on and we leave the other one off, and try flip-flopping those? What if we drop the MTU? We're in AWS, where it uses these jumbo frames with an MTU of 9001 by default. What if we drop the MTU to 1500, let's say? That was okay. We noticed that things will be all right for about 2-3 minutes, and then the network performance falls off again, and there's a whole bunch of fragmentation going on the network flow. So again, it's only briefly acceptable performance, and sometimes it crashes there too. So something I didn't get to update yet in the bug report is that using the latest Flatcar beta, I think it's 3.4.6, something like that. So far, it hasn't crashed for us in our testing thus far. And also, full disclosure, we're using the Calico CNI in Kubernetes with its eBDF data plane active which means that it does make some calls that fiddle around with the SK buff structures. I don't know. I haven't yet figured out whether or not anything that it's doing seems like it would be egregious enough to trigger these kinds of bugs. But yesterday we did also see some checksum failures, and I know that Calico does some stuff with updating checksums on packets occasionally. So I'm here. I have no experience with kernel development or with appealing to the mailing list for help. And I really don't know, again, if this even has anything to do with Flatcar at all. It's the only distribution we've tried using, so I don't know whether the same problem would arise with a different one. Help.
Yeah. So first of all, thanks for the recent messages, especially the stack trace, right? If you can get them without pstore, then that's equally good. It's just a matter of having like a stack from where in the kernel it's happening, right? That being said, I have heard in the past, like with these advanced software-defined network planes, and that you CNI plugins and Kubernetes and GRO and GSO, I have heard of things like kind of breaking. Like also like in simpler virtualization scenarios, I remember times when KVM, GRO, GSO was just simply broken, or I remember a time when there was a FreeBSD guest that just couldn't get DHCP because the frames were invalid, stuff like that. So it's like a tricky thing to find like who's responsible, right? Or like where does the fix need to be? So it's good that you kind of can test different kernel versions, and the question I have based on your story right now is, when you were running 2705, were the other parts of your stack the same? So was it the same Calico version, the same,
I'm trying to remember now whether or not we've been able to test keeping that same Calico version. Unfortunately, we ran into some incompatibilities. Like we found that some of the newer Calicos didn't work on the old enough, on an old enough kernel. So we had to move the kernel ahead to test the newer Calico. And, so I don't have a straight answer for you on that. I know exactly which version we've been using with the 2705 Flatcar, but as we've tried to work through our upgrading lately, unfortunately, it's very hard to keep one thing, say change just one thing at a time, because we find that, again, one part of it will be incompatible until we upgrade something else as well in lockstep. Right now, in our current testing, we've been comparing Calico 321 to mid 323. So, make what you will of minor version steps like that. We see better behavior with the newer Calico, which is encouraging, but there aren't any patches there in the Calico project that address anything that sounds like, there was a bug in this area and we fixed it. It's just digging through their code, what I see is some of their BPF stuff is written in C, and some of it is written in Go that then uses a library to, I don't know if it's compile the programs or generate the code and compile the programs. And so it's possible that even in their dependencies, there could be changes there, right? That generate different programs that we're not seeing the source code change just by reading what's changed in Calico. So
yeah,
I haven't seen anything obvious like, we're generating wrong checksums. Correct that and generate correct checksums now. Nothing is an obvious positive change.
Does Calico only have a BPF backend? Does anyone know that or does it have like the two options?
It has several options. So it has a couple dimensions. It has different data planes, I'll say, where what they call data planes, sorry, where it can use, so it can rely on the Kubernetes kube proxy for forwarding certain traffic. Or if you activate Calico's eBPF data plane, you don't run kube proxy anymore, and it uses the eBPF programs to forward traffic between machines instead. But then it also has packet encapsulation options like IP and IP and VXLAN.
Right. Yeah.
So we're using VXLAN encapsulation with the eBPF data plane. And I think it's still a slightly unusual cocktail there. The number of users worldwide who are doing this is probably few still, even though the feature's been available for about, I'll say, a year and a half at GA quality. So, in a way, we're doing something a little bit weird in that way. I don't think we're running anything against advised configuration, but it's just not that popular. So maybe we're exercising a combination that isn't getting broad use.
Right. That's kind of, I mean, no blame on your side, right? Like there are very many combinations possible, and I do think some of them just aren't tested enough to have all the bugs fleshed out. So what I can offer you is that I'll try to spin up a conversation on the Linux kernel mailing list. But ultimately, I mean, it's going to involve a lot of trial and error and trying out things. So something you can also try, since you say you can reproduce this fairly quickly on anything, right? So you could try, there's two kinds of enhanced networking in AWS, right? There's the AWS native ENA, and then there's some kind of Intel-based enhanced networking for some older instance types, right?
Okay.
So you could try switching a single node to that to see if it reproduces. That way we get some indication whether it might be driver dependent or just general networking, right?
Okay.
If you can try various modes of Calico, I mean, I understand you pick one because it's the best for what you do, right? Yeah. So I mean,
yeah, there is. I did consider trying to compare the behavior with the eBPF data plane, disabled using the other one. There's a crucial feature that we lose there that a bunch of our components rely on. So with the eBPF data plane, it's able to maintain the source IP address on packets that it forwards. And we have certain things like certain, I'll say, authorization steps that are predicated on checking these client IP addresses. So when we lose that data plane, we have to try to recover those addresses through other means, like using the proxy protocol or traffic forwarded through load balancers. It's a lot of other things have to change. It's not an easy thing for me to toggle because migrating into using it was like a year-long thing for us. So it's hard.
It is. Ultimately, I'll have to be like honest. I can't guarantee anything, right? I'm also not. None of us is able to like off the bat like kind of figure out what's going on. So we'll have to just kind of try to talk to various projects and see who can suggest trying what, and at some point we might narrow it down. It is interesting that you say you didn't have this with the 2705 Flatcar release, which I see has a 5.9 kernel. So
we were running on the same kind of machines with the same workload, and
So it might be that at some point we just end up trying to bisect between 5.9 and 5.10.
Right. So if I'll say I'm a little out of my depth on what it takes to produce an AMI for Flatcar, but if we were able to iterate and say, okay, try this one, like you say, we bisect. I've been able to do that with what's released. but like I've laid all this down for about a year where I just wasn't worried about it. You know, we
Right.
found a
Yeah,
version.
makes
We're like,
sense.
okay, don't
Mhm.
touch it. You know, let's go on. Let's do something else for a while. And now suddenly it matters heavily to us. So I lost track of at what point might it have become okay. And like I said, you know, we only have about 18 hours of testing so far, but using this very new kernel with a newer Calico, so far it looks good. And this could be the kind of thing where we never figure out what was really wrong. We just
Don't give us
lucked
hope.
out. And, you know, I feel bad though in the sense that there's a bug somewhere, and I was kind of hoping that maybe like one of the authors of that code would look at the stack trace and say, wait a minute, there's for this value to be this and get here, that's bizarre. We need to back up and figure that out. And
That's why it's worth trying with the mailing list. But as I said, unfortunately, with the growth of or rise of software-defined networking and anything being able to rewrite any packet, there's a lot more places in the stack that just inject random packages, right? So and especially you can add headers left and right and you know, offloads. There will be questions. There will be questions that get asked, and it'll involve more. But yeah, let's try it. Yeah.
I've also tried to drag the two Calico maintainers in that worked on this part of their product. They're understandably reluctant to get too involved. I don't think they're at all convinced that they have anything to do with it yet. So it would also really help if somebody was able to look at this and knowingly say, wait a minute, in order for it to get into that state, you know, it would have had to have come on that, you know, this packet came from the Calico network interface, whenever we need to see what they're doing, you know, like that kind of thing might incite them more than my naive inquiries so far.
Yeah.
So I think where we can come in is facilitate exactly that, where you say you kind of don't have an experience to keep actively engaging, and that is share the bug and the respective information that you provided with the kernel devs who might be able to help. And to our experience, so they basically pulling them to an issue doesn't work, but engaging with them over a mailing list is more productive. So we're kind of collecting feedback. We'll definitely get back to you with probably more trial runs, more things they want. And we have several such engagements done and ongoing actually on other kernel bugs. I think that is where we as a distribution can bring in value and basically cover that for you. The bug itself looks extremely interesting, if you ask me. It's not just the Calico, the eBPF, and the kernel networking side, but the bug happens when you use offloading to AWS hardware. So you know. It's interesting. The thing that will happen on the bug is, as Jeremy said, we start a conversation with the kernel devs, and experience dictates that they'll come back having more questions. We need a few more repros. Maybe we get a clue on what we can do on our end and produce like an experimental army image that you can deploy and then repro things on. We've been doing that for other kernel bugs as well, and basically just iterate on that. But as Jeremy said, there's no clear smoking gun. So this might take a few turns even before we get like a rough direction in which we should look.
Sure, I appreciate that. May I ask entertain a naive question that I've read the documentation about this offload feature, and several of us, my colleagues, have been reading, and we keep flipping around our understanding. When offloading is enabled, is the kernel delegating responsibility to the hardware to do that job, or is when offloading is enabled, is the kernel taking on responsibility that the hardware would normally do? Which
No,
way
no,
is
no.
it?
The hardware does the job. So in this case, we're talking about package segmentation. So when you copy data from your application from user space, it is not in one coherent piece of memory, because that's not how the application usually handles this data when it pushes it into the kernel. Just imagine like multiple socket writes. And the thing you don't want to do is you don't want to like memcopy all of the stuff. So you're basically in the kernel, you're handling with addresses and offsets. And then you can assemble all of those fragments yourself, which then probably will result in memcopy, or you just ask the hardware to do it for you. If I have like my extremely naive understanding of the black magic that is the networking subsystem is right. And we're basically talking about pointers into raw memory. So that's very exciting for everybody involved. This is what makes this issue so fun. But yeah, offloading means let the hardware do the job, because for the kernel it would be more work to do. And you would notice at some point it's only single thread performance that hits, because everything needs to be consolidated before it's being sent off. And that's where you notice a speed impact if you turn off offloading.
Okay. So that's where it comes up, like you say, that AWS's drivers, let's say, could be at fault. Because
not the drivers, the actual hardware.
Oh, the hardware. Okay. Because when we turn offloading on, that is now performing that responsibility.
But I mean, this is basically just getting the list of like everybody who could be involved, right?
Yeah.
I just remember a case where we had IP encapsulation, and in that, I think we built a VPN without encryption, something similar to what Calico does when connecting nodes over tunnels, and we had fun with a Marvell chip that also supported TCP fragmentation offloading, and it broke everything. It broke TCP checksums. It didn't crash the kernel, but it just made the data invalid. And it turned out to be a bug in the Marvel driver hardware interoperation that in a new major release of that driver was fixed, but it remained broken for, I think, a few years.
Wow.
No finger pointing to Marvel, by the way. They're awesome. It can happen to anyone.
Fair enough. I will check out that Mantle link that you sent, Kai. But okay.
We'll get back to you on the issue as soon as we hear from the kernel folks.
Okay. I appreciate you hearing me out. Thank you.
Sounds like you found yourself in a nice, perfect storm interjection of like a lot of exciting technologies. However, when so personally, I come from a background of support engineer and like managing support and enterprise support for many years. So when it comes to networking issues and like, being on the cutting edge, that's really fun place to be. It's exciting. I got on mute and challenging. Right. So growth opportunities, if I segue back to that, maybe it was like the right thing to say. So that was like the last item on the agenda. And then we have like a recurring item, which is talking about the release. So Sayan, are you here? It's like pretty late for you there, right?
Yeah. Hi. Yes, I'm still here. I'll share my screen. Yeah. So as mentioned in the agenda, we will be having the release for stable. So we had the alpha release and the beta release last week, and as you mentioned that just to make sure that we don't break stable workloads, we had introduced the step where we release the stable after release the stable and the LTS after a week. So soon after this meeting gets over, we'll start off the build, so expect a release in next 1 or 2 days. So that throws this stable release out of the door. So one thing I wanted to know was we did a alpha major bump last week. So technically, I think we always did a bump whenever stable bump whenever we did a beta bump. So I think we should. I think we should do a stable major release this time. Is there any concerns with that? Okay. I cannot see screen, so I see Matthew raised. Gave a thumbs up. So I think we can go ahead with the major stable release for this release. Okay, so moving on to next. So the next release, as we told in the last meeting, in the release planning meeting, that we would be moving on to our older 2-week cadence. So we briefly moved to 4-week cadence because of the team workload and the release of the new CI pipeline. With the CI pipeline out of the door, we will move to the 2-week cadence. And so we would have the next release in approximately like in on 24th. So this is around 3 weeks time, but over time by November we think we'll find the good balance between the release planning meetings and the releases. So the next release would happen on 24th of October. We have a couple of updates already in which are merged, and a couple of them are getting worked on. We had a Vim update which fixes a bunch of CVs, but then we had a bunch more, so Casimir is working on that. And there are a few other security fixes for the packages, so that is getting worked on. Yeah, so did not get much time to work on the with the system D with the and the NVIDIA drivers in the last week, so that's something I'll start to work on. Anybody else working on any other issues that which you would like to point out for the 24th October release? Is the tab visible, right? Or no?
Sorry?
The tab is visible, right? I mean, the screen share is visible, right?
Yeah.
Oh,
Because
yeah. I'm sorry. I didn't mean that. Sorry. I just meant if I try to follow your hyperlink, it tells me 404 is like it can't see any of the projects for Flatcar.
Oh.
Okay. We need to see into that then. This should be public. This should not be private. So yeah, we'll look into that. Okay. If not, then we can move over to the next agenda. I mean, I guess that's the end of the meeting, and hand over to Daniel.
So actually, I guess that was the last agenda item. Thank you all for staying. It was like exceptionally long meeting this time, where we had a really packed agenda. But I think it was also fun. Try to keep it lighter for next time, or if we see it like, staying so packed, maybe we have more frequent meetings. But let's see how it goes next time.
Thank you very much for hosting.
Oh, and Steve, you
Yes.
noticed that you don't have access to the product?
Right. So if I go, I first just tried that hyperlink, and then I, walked stepwise up the path, and it shows me complete empty view for GitHub projects for that org. So
does the link work for you that Cyan posted? And
that one, no.
Okay.
Wait. No, I'm wrong. Now it works. So I had tried it. Tried the one that was on the. Let me see. Okay, that's interesting. So the link that you posted.
I see it. Oh. That's a interest. The link in the agenda is actually outdated because we moved orgs from Flatcar Linux to Flatcar, and we didn't update our agenda.
That's annoying that it doesn't just redirect for a while.
Yeah,
that
makes sense. Yeah. But anyway, so that bug is easier to fix. We'll handle it.
All right. Sorry for the noise. Yeah. Now I see the problem.
No, that's good input. No one from us has seen it. So actually, great find.
Solving problems, Dave. All right. Cool.
Okay. So thank you all. Have a nice afternoon, whatever is happening with you. Night. Okay.
Catch you later.
Bye.
Bye.